Hey, I'm Seth, CTO at Lulzbot here in Loveland, Colorado. This is our new Taz three-dimensional printer. As you can see, it's pretty robust and reliable. You really can do whatever you want with it. Seems to just not really care. Thanks for watching, and remember to check out lulzbot.com.
The Lulzbot Taz is a versatile, high-performance desktop 3D printer for industrial users that respects your freedom to create. The LCD control panel and SD card reader offer 3D printing without being connected to a computer. The heated borosilicate glass bed with PEI print surface keeps your prints adhered to the bed while printing and releases them cleanly when cooled. With one of the largest build volumes of any desktop 3D printer, the Taz 5 offers room to bring your big ideas to life. The all-metal hot end, capable to 300 degrees Celsius, enables printing in a wide range of materials, including HIPS, PLA, ABS, nylon, polycarbonate, polyester, and more. With all these great features, award-winning quality, and excellent customer support, it's no wonder the Lulzbot Taz 5 won Best Overall in Make Magazine's 2016 Ultimate Desktop Fabrication issue, and is a Tom's Guide Editor's Choice as Best Enthusiast Printer.
Barcodes provide machine-readable identifiers that can be used to track parts through manufacturing and distribution. The Ember 3D printer can print very small barcodes using the same resin used to print the small parts they identify. In order to make the codes legible by barcode readers, there must be high contrast between the cells and the spaces between them. With a single color of resin, differences in printed texture can provide that contrast. Start by creating a bitmap image of the barcode you want to print. There are free online tools that generate various types of barcodes from an input text. Now we need to process the barcode. With DLP printing, you use image masks to choose where the resin will solidify. If we use just the plain black and white barcode, we get raised flat areas where there were white pixels, and lower flat areas where there were black pixels. But if we look down from the top, the way an automated camera would look at the barcode, it's very difficult to see. We can only infer the barcode from the shadows. To increase the contrast, we give the background a checkerboard texture. So when it's printed, the shadows of the fine texture create a distinct difference in luminosity with the pixels of the barcode. The smallest 10x10 barcode here is only 1 square millimeter. This process for 3D printing barcodes was developed by Richard Green of the Ember team. If you want to know more, check out his Instructable linked in the description. Subscribe to the channel if you'd like to learn more about DLP printing, and have a fantastic day.
Design. You can do the whole design, or it's only like block printing. Like you say, like the layers here. Here you're doing layers, and it's all one color layer. Yeah, it's kind of like blocky. Can it do can it print Earth? So let me show you here. When we first developed this, our first prototype, we were only capable of this right here. So you see how the transitions between the colors are very blurry, and it kind of mixed.
Hello and welcome back. The first step in making our mini console 3D printer is to make our 6 diagonal arms. In order to make these 6 diagonal arms, we'll need 6 pieces of carbon fiber tubing 180 millimeters long, 12 M4 pieces of all thread 20 millimeters long, a bag of these Traxxas 5347 ball joints and sockets, which should contain 12 of each at least, some epoxy, a pair of pliers, and an M4 tap. Our first step in building the diagonal rods is going to be to thread these little ends for the ball joints here. We're going to use our 4mm thread tap to do that, and what we do is just stick it in there as straight as we can, and I like to keep the tap still and spin the actual ball joint end. And I just keep wiggling it, make sure it's on there straight so that the thread's straight. And once it's in there, you'll start to feel a little resistance at cutting the threads. Wiggle it back and forth once you know you got it straight on there. And in this way, you're actually tapping the end for the threads for our little 20mm ends there. You're going to do that with all 12 of these plastic ends. When you get it threaded enough, you'll actually feel the tap hit the end of the hole. And you've done it right. Pretty much all of them are going to go about halfway in. So you'll see there. That's one that's been finished. And once we're done, we'll actually glue those in. Now we've got our little ball joint ends threaded out. We're going to go ahead and glue in this piece of all thread here. I went ahead and mixed up a little bit of epoxy. We just dip the end in there. You see it has a little glob on it. Then we're going to go ahead and screw that on there. I'm going to screw it all the way in. So it's all the way screwed in. We're going to wipe off any excess. Let it set, and we're going to repeat that for all 12 of these. The last step in assembling the diagonal arms is to take our end pieces, put some glue on the end, and insert them into the rod, removing any extra glue. Once you've done that on both ends, at that point, insert the diagonal rod onto your jig to ensure that everything dries straight and that all of the rods are the same length. We will repeat this with all 6 rods. Now that all 6 of the diagonal rods are glued and in the jig, I reattached the back side of the jig. That verifies that the distance from this dowel to this dowel is 215 millimeters, not only in the front but all the way across, and that these two are parallel. This ensures that all of our diagonal rods are the same length and orientation. Now, while these set, I can go ahead and start putting the frame together.